Hi, everyone, and welcome to episode 6 of my little mini series, Fundamental Trig Identities. So far in this series of videos, we've went over what are the fundamental trig identities. We've went over how do I factor in a variety of different methods. And then we just wrapped up how to simplify. So in order to be proficient at verifying and then eventually proving trig identities, you first have to have your trig identities memorized. They're back here on that lower left-hand corner. You have to have those memorized. If you have those memorized, everything becomes so much easier. I would highly recommend making some flashcards. There's Quizlet that you can make, things like that to make sure that you have those memorized. You also need to be good at factoring, and you have to be good at simplifying. If you're not proficient at those two techniques yet, then verifying is going to be challenging. So verifying is essentially a simpler form of proving. When you're verifying, you already know that the identity is true, and you're going through the algebra to show why it's true. There are a few guidelines for verifying. When you verify, you're going to be given an equation. It's going to have a left-hand side and a right-hand side. And the first thing you need to do is you need to pick the more complicated side. You are only allowed to manipulate one side of the equation when you're verifying. And it is a lot easier to take something that is pretty complicated and make it simpler than to take something that's simple and blow it up. So the first thing that you're going to do is you're going to pick the more complicated side. The next thing you want to do is you want to ask yourself, can I algebra? Now, algebra encompasses a lot of things. Algebra encompasses factoring, simplifying, using a conjugate, adding or subtracting fractions, getting rid of square roots. All of that is algebra. And so you want to look at your equation and essentially ask yourself, can I simplify it? If you can, do that. The next thing you want to ask yourself is, are there any identities? This question is so much easier to answer if you have these memorized. If you have those memorized right there, then all of the sudden, your questions that you are trying to answer start popping out on the page. You see a secant squared of x minus 1, and you know, oh, that's tangent squared of x. You see a 1 minus sine squared of x, and you just know, oh, that's cosine squared of x. And these start to become fun. They're little puzzles that you want to solve. But if you don't have these memorized, if these are foreign to you, if I say sine of x is the same thing as 1 over cosecant of x, and you're still like, what? Wow, where did I get that from? No, then you're going to cry. Just being real with you. You're not going to know where things came from. Make flashcards on these. Do something. Get these memorized. Get them into your brain. So 4 is, are there any identities? Or that's 3. 4 is, nothing's working. Nothing's working. The identities aren't working. I don't know how to algebra. Then change everything to sine and cosine. You will be surprised by how many of these trig identity verifications come to life when you start changing them into sine and cosine. When you start changing them into sine and cosine, things start canceling out. Things start to just make more sense. We're more comfortable with sine and cosine. And so if nothing else is working, change it to sine and cosine. And then the last thing, don't give up. I'm literally going to write that. Don't give up. These are challenging. But what better way to grow and learn and be a successful human being than to persevere through a challenge? Don't give up. Try something. There are some questions that you're going to do an entire page of work and you're not going to go anywhere with it. And you're going to be like, crap, what do I do next? And then something is just going to click and you're going to find another way to do it. All of these questions, there's infinite different ways to solve them. And that's okay. You are never going to go the same way that your neighbor did. And that's okay. So don't give up. All right, we're going to do a verification. Let's work through one. And I want you to know that maybe I didn't do this the same way you would do it. That's okay. It doesn't have to be the same way as you, as long as you can prove every step along the way. Okay, so we're going to verify, and I'm going to write down here secant squared of theta minus 1 over secant squared of theta, and all of that in the end is going to equal sine squared of theta. Now here's the deal. When you're verifying, you already know that it's true. You already know that it's true. When it's verifying, it's already proven that it's true. And you could reasonably plug it into Desmos. I want to make this smaller so we can see it. You could plug into Desmos that you've got secant squared of x minus 1 divided by secant squared of x. And we are trying to prove that same thing as sine squared of x. It is. It's the same thing. Your goal is to show through algebra why it's the same thing. So we have to go through step by step. Why is this the same thing? So just like we wrote down up here, our first step is to find the more complicated side. This one's pretty easy to determine which one's more complicated. This is obviously more complicated than sine squared of x. Sine squared of x is easy to plug into Desmos. It's easy to plug numbers into. It's easy to visualize. This is a little bit harder. So we're going to pick the left-hand side as the more complicated side, which means I'm not allowed to touch this side. But this side over here gives me so much information because what I know is that in the end, I need a sine squared of x. And really, if I'm thinking about this, not only do I need a sine squared of x, I know that sine squared of x is the same thing as 1 over cosecant squared of x. So if I can get to 1 over cosecant squared of x, then I can get to sine squared of x. So I'm thinking already about these identities on my page. So we're going to start with that left-hand side. If you have these memorized, something's already jumping out at you. If you have these memorized, you have noticed that you have a secant squared of theta minus 1. So secant squared of theta minus 1, it's right here. Secant squared of theta minus 1 is exactly the same thing as tangent squared of x. So you can take this business right here, all of that, and you can replace it with a tangent squared of theta. Of course, that secant squared of theta is going to stay the same. And we're not going to touch that sine squared. But we know we're not done yet because we don't have a sine squared yet. Okay. Some of us right now notice we have a secant squared in our denominator. And if we have a secant squared in our denominator, that's the same thing as just multiplying by a cosine squared. Some of us, we're not at the point where we can see that yet. And so we need to work through our fractions still. I want you to know that this is the same thing as tangent squared times 1 over secant squared of theta. These two things are equivalent. The reason why is because there's a little ninja 1 over 1 right there. And when you multiply fractions, you multiply straight across. Tangent squared of theta times 1 is tangent squared of theta. Secant squared of theta times 1 is secant squared of theta. Remember, there is a little ninja 1 here. So it's a little over 1. Tangent squared of theta divided by 1 is just tangent squared of theta. So if you were to multiply those things straight across, then what you would get is tangent squared over secant squared. So those are equivalent. Now, hopefully what you see is you see this 1 over secant squared of theta. 1 over secant squared of theta, it's right here. 1 over secant is cosine. So 1 over secant squared has to be cosine squared. So this right here, I'm going to leave the tangent, is going to be tangent squared of theta times cosine squared of theta. That comes from this piece right here and this piece right here. I don't know if you guys can, like, hopefully you notice that my hand is also right here. It's crazy. Are we done? We're not done, because our end game is we have to get a sine squared. Now, if you're worried along the way, did I make an error? Where did I make an error? You can always pull Desmos over, and you can type every single step along the way. So this is still overlapping. I did not make an error there. This, you have to put parentheses around this. This is still overlapping. I didn't make an error there. So you could make, Desmos show you every step of the way, am I doing this correctly? You do have to, get comfortable with the way that Desmos wants you to type things in, but there we go. Every step of the way. I have not made an error yet. All right, we're almost there. Again, if you have these memorized, things are so much easier. So right now I'm looking at this tangent squared, and in my head, I'm like, oh yeah, I know exactly what I need to do. And in my head, I'm already saying, woohoo, because I know that I have the right answer. I know deep within my soul that I have done this correctly, because tangent is the same thing as sine over cosine. So tangent squared is sine squared over cosine squared. And of course, we're multiplying that by cosine squared, and there's a little invisible 1. And what happens is the cosine squareds cancel out, leaving us with just sine squared of theta. And that is what we wanted to have. And right there, I say, woohoo! And I'm so excited that I just verified this identity. So as you're working through, look for any of the identities. Change them along the way. Don't give up. Just keep on going. Maybe you did this a different way than me. If you plugged it into Desmos every step of the way and it was equivalent every step of the way, then you've done it correctly, right? Like, there's infinite different ways to do it. But I hope this video helped you see one way to go through this identity.